This is the Olympus NDT ERW In-Line Medium Range Inspection System. This system is designed for the inspection of ERW pipes as an inline application with a range from 2 3/8 inches up to 9 5/8 inches. A similar system to this one, based on the same inspection concept, can do an inspection of the large diameter range, starting at 4 inches up to 16 inches. The system is a turnkey solution that includes the inspection acoustics, electronics, mechanics, and control. The configuration of the system includes a gantry portal that is holding the inspection head. In the inspection head, we will find the acquisition electronics. The acquisition electronics is a quick scan LT 32-256 unit capable of firing 2 parallel apertures on the same probe. We are using 3 quick scan units in this installation. Each quick scan is connected to one phased array probe. On the inspection head, we find 3 different layers. The 3 layers are mechanically identical, and on each layer we have a phased array probe. Each probe is capable of rotating around the pipe up to 180 degrees. From an inspection point of view, each probe is performing a different task. The first probe is dedicated for weld tracking. Probe number 2 and number 3 are going to perform the clockwise and counterclockwise inspection on the weld line. The water wedge is mounted on a yoke that can be easily taken off and reinstalled in place. This design allows a very fast changeover process when it is required to change the probe due to an extreme size change in the production. As part of the system, we also find the calibration stand. The calibration stand is used in 2 very important sequences for the inspection system: for calibrating and checking the calibration. During the calibration process, the calibrator is going to position the defect that we are going to calibrate precisely under the probe. Probes are rotated around the reference notch. This allows all apertures on the probe to be adjusted at the same sensitivity level. During the calibration sequence, we will start by calibrating on a reference defect, with the probe inspecting the first side of the weld. In quick view, we can see the signal response of every aperture of the phased array probe as it is going over the reference defect. The goal of the calibration is to equalize the response of every aperture to a target of 80% plus or minus 5%. After the first pass, some of the aperture were not at the 80% response level, so we must calibrate all of them by adding or removing the gain level for each aperture. Now, as you can see, after the second pass, the calibration is perfect. We can now move the probe inspection to the other side of the weld. Again, the goal here is to equalize the aperture response to 80% plus or minus 5%. The operator has the choice to select which aperture needs to be calibrated, or the operator can select all the aperture at the same time and confirm the choice with the Quick View acquisition software. Once the operator clicks OK, calibration gain is added or subtracted to the corresponding acquisition gate. After the second pass, the calibration is perfect. The check calibration process is a dynamic verification of the system calibration. The reference pipe is moved under the probes using the calibration stand at the same speed as the production line. The calibration stand can travel up to 1 meter per second or 200 feet per minute. Acceleration of 8 meters per square second allows it to accelerate in a very short distance, ensuring scanning the reference defects at the nominal inspection speed. During the check calibration sequence, QuickView will record the amplitude response from the reference defects. For the check calibration to be successful, we have to detect all of the defects over the alarm level. As you can see, this check calibration was successful as all the defects were detected above the alarm level. For protecting the system, we use a combination of an encircling coil and an eddy current Nortec 500 instrument. This protection system is designed to detect openings on pipes that could damage the inspection probes. The coil is designed to detect the variations in the magnetic field created by the material variations coming, for example, from an opening on a pipe. Any magnetic field disturbance in the coil is going to generate an alarm that is going to be detected by the PLC, and it will trigger the raising of the inspection probes. For more information on Olympus ERW In-Line inspection systems, please contact your local representative or visit us online at www.olympus-ims.com.